Imagine you have a dream in which someone takes the most primordial, unchangeable universal constants upon which the whole universe is built, like the speed of light or the charge of an electron, and then uses a basic number-letter cipher to convert the letters in those constants into a hidden message. So let's take them in pairs. 29, that's past 26, so you've got to continue with the alphabet. That's 27 is A, B is 28, 29 would be C, so we start off with C. 97 is S, and the other two letters make N, and then S again. That gives CSNS. Like in this dream, you shift the cipher by the number of dimensions in the universe. I had to look it up, it's 10, apparently. And this would give you MCXC, which looks like gibberish until that's M, C times C. C times C is squared. C squared, it's MC squared, is hidden in the speed of light, the formula, Einstein's formula. Okay, I see your objection. I could have shifted it by 11, by 12, by 194 until I found something that looked interesting. Yeah. It's not like I just converted it straight and it spelled out the name of the person who discovered it, you know? But just before I move on, who did first measure the charge on an electron? His name was Millikan, Robert Andrews Millikan. And this time I'm not going to shift by 10, I'm just going to do a straight conversion. The mass of an electron constant 9109383701 spells out 91 is M, 09 I, 38 L. So I woke up the next morning and looked at this script and thought, what has this got to do with question 2, 2022? And I don't remember. There was some connection, I'm sure, between this and 2022. But anyway, I woke up in the morning, I couldn't remember what it was. So let's look at question 2. It says, what is volatile memory? Well, if you look at the marking scheme, it says that it is any kind of memory that does not persist after the computer is switched off and turned back on again. You know, it actually is very similar to, if you think of ethanol in chemistry, like a volatile liquid. You know, you leave it in a jar overnight, it just evaporates. Stinky volatile liquids evaporate away very quickly, and that's the same as computer memory, like RAM or registers. If you just yank out the power cable, whatever was in the RAM is gone. Do you know what I mean? It wasn't written to the hard drive. So it is literally like going to bed and waking up the next morning and just not remembering what was. Okay, I now that maybe that's what it was. So the best way to understand computer memory is just to compare it to human memory. And there's we'll take 3 examples and we'll look at the 3 equivalents in human memory. So start off by trying to remember this number, 94086014920431. Generally around 7 digits in, that's your working memory, you will fail to be able to recall these numbers. For me, I feel like it's about 5, but most people can do about 7. Right, so that's your working memory, and that's very much like your RAM. It's the numbers floating around your head that you know. So someone says add these 4 numbers, and then this 5th number. So you're constantly, you know, swapping things in your RAM in your head. Right. The next morning, if you wake up, you won't remember what those numbers are unless you wrote them down. Okay, so it's fast. You can do it in your head. You have to write it down. You frequently swap out the information, and all this carries true over to RAM. Like that working memory in RAM, you could write those down in an exam as like, oh yeah, it's fast, you know. So I think that will help you understand it. Whereas if you're writing down numbers in your journal or a maths copy, that's like writing to a hard drive, you know, or a flash drive or a CD or a DVD or whatever, some kind of permanent storage. Like that's non-volatile, so that does persist, you know, for a long time. And the last one is kind of like your sensory information. That would be like inside your brain, it would be like just a few neurons in your brain, just maybe in your earlobe, or, you know, picking up the raw sound from someone's speech, or the photons of light landing on the back of your retina and then going down, and they haven't been processed yet. Do you know what I mean? That's like the registers in your brain. So just going back over, we had those three things. We had the very smallest, the registers, which were just like in your brain, like your sensory memory, you know? And then we had the RAM, which is like your working memory. And then we have, you know, written down stuff. And that's like non-volatile, kind of secondary storage, like hard drives and that sort of thing. So let's look at the exam solution here now, and hopefully all this will make really good sense to you. So the question was, describe two differences between registers and RAM. They didn't actually ask about long-term secondary written storage this year, but they probably will another year. So good to know. And that's why I did all three. Physical location, as we said, look, the registers are inside the CPU. The RAM is the clicky sticks. The sticks of RAM you slot in and satisfyingly push down to the go click. I should probably got the microphone and recorded the sound of inserting RAM, which is pretty amazing, and a new smell of new computer. But you'll just have to use your imagination. Access time and speeds. We talked about registers being a lot faster than RAM, and RAM in turn is more better than secondary, like hard drive storage. So that's the kind of hierarchy. Registers faster than RAM, RAM faster than secondary storage. We're just talking about the first two, so that's what we're going to say here. But just watch out. You need to, if you say one is faster, you need to say the other is slower. You have to complete the sentence. Don't just imply that because one is up, the other is down. You'll lose marks for that, and it's so annoying. Because clearly the student understands it, but you're like, Anyway, just exam tip, strategy. Cost. Registers are more expensive than RAM. I like the way it says per byte. Yeah, I guess so. Because like you could argue that the other is true if you don't go per byte. But anyway, look, it is true per byte. Capacity. We talked about how RAM holds way more. It's in like the gigabytes. You know, registers, you're in the like just tiny amounts, like literally bits in registers. And then, you know, secondary storage like hard drives and disks, you're talking gigabytes, terabytes, and all that jazz. Material, they're made from different materials. You don't have to go into what materials, but I suppose you could argue. It says any other valid difference. Because these differences and contrasting questions come up quite a lot, someone in my class came up with the mnemonic STEM. So that's safety, time, easy, money. Because sometimes you just can't remember what headings to contrast them under. So if like that's very useful in a lot of questions like cloud computing versus like local storage, which is safer, which is easier to use, which saves you time. So if you go safety, time, easy, money, I suppose it would do a few of them for sure. You've got time in there, which is faster if you couldn't remember. Which is easier to replace. Well, it's a lot easier to just pop in and out RAM than it is, like taking out the thermal paste from a CPU or extracting a register from a CPU, which is impossible, right? Unless you've like got you're in a computer manufacturing machine. And then money, that was cost. You see what I mean? Like STEM, it works really well for like a lot of these questions. So maybe just remember that. I find that's like the best thing I've learned in 2024. So kudos for whoever came up with that. You know who you are. I'm not sure I can legally mention you in the video, but you know you're the hero.